Student, good morning to all. Assalamu alaikum. So today we are going to start a new chapter, Unit 4, Work, Energy and Power. Let me see the introduction. Work, as you know that without any work there is no changes of a body. If you take any things, any materials, the changes of position and the changes of direction will be explained in terms of work. So without work there is no changes, isn't it? So you can look at here the definition of the work: the ability to do work for energy. And similarly, for energy changes we are doing work, for work changes we are spending some energy. So both these two will be interrelated concept. And here the rate of work done is called power. That is different topic. Now today we see the important topic as work, how work is takes place in physics. That is, look at the equation here: work which is equal to force into displacement. That is the basic formula for work. Here you can see W is equal to F into dr cos theta. This means work is equal to force into displacement. Here in the displacement they are given dr cos theta. So here look at the diagram calculating work. The direction of force is in this direction, and the base, that is F cos theta, that is displacement takes place from this point to this point. So this is, we have to understand, the direction of force will be above direction, and the distance we are calculating from above to the starting point, this will be give you F cos theta according to trigonometrical relations. Basically work means that is force into displacement. Okay, now come to see work done by constant force. Here the work done by constant force. So we are applying the force on a body. How the force will behave while we are doing some work? So look at the relation here. When a constant force F acts on a body, small work, that is dW, by a force in producing a small displacement dr. So here you can see we are doing small work. So based on the small work, how the behavior of the body in terms of force, that will be give you dW, which is equal to F cos theta dr, as we had seen starting relation. So similarly, total work done in producing a displacement from initial position Ri to final position. So initial position to final positions. A body, for example, a body changes the position from initial to final, from one place to another place. So the one place, that is the starting initial place, the final position, that is the ending place. So that is Rf. So Ri to Rf will be give you integration. So W is equal to integration Ri to Rf dW. So I think you know the integration. Integration means we are finding the limits from one position to another position, that is using the limits we are calculating the integration. So here dW is equal to first equation 4.3 F cos theta dr, which is equal to F cos theta taken outside because that is a constant taken outside. And what is the variable? Variable will be dr. Dr is the displacement. So from starting Ri to final Rf, we are producing the displacement dr, so which is equal to F cos theta. Substitute the limit, upper limit Rf minus lower limit Ri. So this is a 4.5. You look at this graph. X axis we have taken displacement R, and y axis we have taken F cos theta, that is force. So x axis displacement, y axis is a force. So if you calculate this graphical representation, you will get like this relation. It's a rectangular block like structures you will show. This is the work done by constant force. So here this is the work done for constant force. Now come to the very important topic for work done by a variable force, that is reduced portion. This is not there here, this is reduced portion. energy. So kinetic energy. Energy means you know that one. Basically, it is also one of the physical term, energy. So here two types of energy: potential energy, kinetic energy. This is the second type, kinetic energy. So kinetic energy means by virtue of its motion, and for potential energy we know that one by virtue of its position, that is potential energy. No, this is kinetic energy. It is the energy possessed by a body by virtue of its motion. So any body which is moving, that will possess kinetic energy. Now come to see this important topic, work energy relation, that is work and energy, how this work and energy is taken as interrelated form of physical quantities. Let me see, work and energy are equivalents. This is true in the case of kinetic energy also. So for kinetic energy also it is very much related words, related behavior as work and kinetic energy. So to prove this, let us consider a body of mass at rest on frictionless horizontal surface. So the work done by the constant force here for a displacement is in the same direction. Here you can see very simple formula, work is equal to force into displacement. Here using the letter S. S denoted displacement. So force into displacement, F into S. So the constant force is given by the equation F is equal to ma. So this is, you know that one, as we have to see this force is equal to m into a. So for force is equal to m into a, they are given in place of a, they are using v square minus u square divided by 2s. This will be using from the relation, as you can see here, v square is equal to u square plus 2as. That means what? Here this is the equation of motion, third equation, v square is equal to u square plus 2s. So for this, a is equal to v square minus u square by 2s. So this value is substituting Newton's second law, F is equal to ma. So m into a in place of a, you can substitute this value, v square minus u square by 2s. This is the equation 4.9. Now let me see next one. Work is equal to this, you can look at equation 4.7, F into S. Here F value this one, m into v square minus u square by 2s into S. S means that is the displacement value. Just to substitute this value, you will get, separate this value, mv square by 2s minus mu square by 2s. So for this it will come like this, w is equal to this is m into v square by 2s into s minus m, and see this relation, let me go you as, just understand this one. This will become you as v square by 2s into s minus m into u square by 2s into s. So w is equal to half, s will be cancelled. Now this will come as w is equal to half m into v square, m into v square minus half m u square. S will be cancelled here, and this will come u, w is equal to half m v square minus half m u square. This over, the expression for kinetic energy will be u. Finally it will come like this, as you can just look at this equation, term half mv square in the above equations in the kinetic energy of body of mass m. So this will come finally k is equal to half mv square. That's all. This is very simple for finding the work energy relations. W is equal to delta k into E, half mv square minus half mv square. Thus this work energy will be proved. Both are interrelated topic. That's all. With this I conclude this class. We can continue this class in next period, next session. Thank you.